Okay, so we're going to test review for the gas laws test. The best way to see if you know what you're doing is when I advance the slide in this video, when you see the question, pause the video, try to answer the question, and then resume the video to see if your answer is correct. So get your calculators and pencils ready because we're going to have a test review for test 3D. So Avogadro's hypothesis about gases is that gases at the same volume, temperature, and pressure have the same number of molecules. And we already know this from doing stoichiometry. If you remember, we use the mole map to convert from liters to moles and from moles to molecules. So as long as we didn't have to go through mass, every substance that is a gas has the same, at the same volume, temperature, and pressure, has the same number of molecules. All right, so what law would you use to solve this problem? The pressure in an automobile tire is 1.88 atmospheres at 25 degrees Celsius. What will be the pressure if the temperature warms up to 37 degrees Celsius? So assess your variables that you have for this problem, see what you're trying to solve for, and see what the units are on the pieces that you have. Pause the video. Okay, so the video is resuming and you are seeing that you have atmospheres, that's a pressure, and you have temperature, and you have another temperature. So you have a change in circumstances. So remember, we have basically two different kinds of problems. And if you have a problem where there's a change in circumstance, it is one of the three named gas laws, or you can use the combined gas law to solve it. So this one is pressure and temperature, and pressure and temperature. And so I'm going to use Gay-Lussac's law. That is P over T equals P over T. Remember that when you have degrees Celsius, you have to convert that into Kelvin by adding 273. You cross multiply and divide. You always start on your calculator on the path that you have both of the numbers. So the path where you have both numbers is the 1.88 and the 310. And then you hit divided by 298. Your answer is going to come out in the units of atmospheres because the original units on your pressure is in atmospheres. So my new number is going to be 1.96 atmospheres. Which law would you use to solve this problem? Pause the video. Okay, so I hope you see that you had a volume, you have 0.0620 liters, and you have a temperature. And they're asking you if the temperature is lowered to standard, what will the volume be? The question says, what is the volume? All right. So in a balloon that occupies 0.620 liters at 25 if the temperature is lowered to standard. So the law that you would use to solve this problem is Charles's law, because we have volume over temperature equals volume over temperature. So because they're asking you, what is the volume if you lower the temperature? So they're changing a circumstance. So we set up our problem as 0.62 liters over 298 Kelvin, that's 25 degrees plus 273, equals, I don't know, that's what I'm solving for, is volume, if the temperature is at standard. So that's 273 Kelvin, which of course you know is 0 degrees Celsius, but we never do a problem in Celsius. So you take the path that you have both the numbers on and put it in your calculator first. That's 0.620 times 273 equals, divided by 298, because that's the path that's attached to your variable. Your variable is going to come out in liters because the volume on your original number was in liters. So your new answer to what the new volume will be at standard is 0.568 liters. What law would you use? Pause the video and figure it out. Ideal gas law is what you'd use here because you'll notice they're not asking you to change any circumstances. You only have one of each piece of the puzzle, and you have moles. And the only equation that calculates involving moles is the ideal gas law. PV equals nRT. Remember, the ideal gas law has to be put into ideal conditions in order to solve the problem. So be careful. The ideal gas law must be pressure, could be in any units that you want. And this one is in atmospheres. But the volume has to be in liters. If it's not, you'll have to convert it. By the way, this is calculating for volume, so it's going to come out in liters. The N stands for the number of moles, and in this problem, it's 0.323. The R is a set value. It's a reference number, and it will be provided to you on the test. And the temperature is going to have to be in Kelvin, like all of our other gas law problems. So when you pull out the pieces of the puzzle, the 0.9 atmospheres times, I don't know, that's what I'm solving for, calculate the volume, equals the number of moles times the reference number for atmospheres. They have to tell you that number. And times 265, because they already gave me the number of the temperature in Kelvin. So how do I solve this problem? You always start in your calculator on the side that doesn't have a variable. So you're going to multiply 0.323 times 0.0821 times 265, then divided by the number that's attached to your variable. So divided by 0.900. Your answer comes out to 7.81 liters because ideal gas law's volumes are always in liters. This is the reference number. It's a little late to give it to me now, but it will be given to you at the top of your test. It was this number. All right, pause the video, figure out which problem you'll use. Hopefully you notice this is also an ideal gas law because you're trying to find the number of grams. And the only way you can find the number of grams of a substance using gas laws is if you solve for moles and then use your mole map to go from moles to grams. Remember your mole map from stoichiometry? So the equation is PV equals nRT, and the reference number for torr, because they've given you 600 torr, is 62.4. So you set up your problem with the pieces that they have given you. 600 torr, that's pressure. That's the P. V is volume. They gave me 850 milliliters, but you'll notice you have to put it in ideal conditions, which means in liters. To make milliliters into liters, you move the decimal point 3 places to the left, equals the number of moles, which is what I'm solving for, times R, which is the reference number provided, times T, which is 450 plus 273. If you have C, add 273. So when I solve this problem, I end up with solving for 0.0113 moles. Now I have to get from moles to grams. How do you get from moles to grams? If you have moles, you multiply by the molar mass. So you have to know the molar mass of carbon tetrachloride. So that's 1 carbon and 4 chlorines. 1 carbon and 4 chlorines adds up to 154 grams. So a carbon is 12, and chlorine, remember, is 35.5 each, and you have 4 of them. So if you take the number of moles that you have and you times it by 154 grams per mole, you're going to get 1.74 grams of carbon tetrachloride. Pause the video. Welcome back. You know you should have used Gay-Lussac's law if you assessed what you had. You had atmospheres and temperatures. Atmospheres, and they asked you for a temperature. So the problem that you're going to use is pressure over temperature equals pressure over temperature. And you're solving for the initial temperature. That means the starting temperature. So helium gas in a cylinder is under 1.12 atmospheres of pressure. This was in your assignment on the mixed gas laws problems. And this says period. And then it says at 36.5 degrees Celsius, the same gas has a pressure of 2.56 atmospheres. And it's asking what's the initial temperature. Okay, so you have to make sure you put the numbers together that go together. Remember, as always, take the path that you have both of the numbers. So that's 1.21 times 309.5 divided by the path that has the x on it, your variable. So divided by 2.56. And your answer comes out to 135 Kelvin. Remember, if you're solving for a problem that's temperature, you have to take away 273. Because if you have C, you add 273, as we did up here to solve the problem. But if you solve for K, you have to take it away. So that means take away 273. And your answer comes out to a negative 137.6 degrees Celsius. On the test, if you need a degrees Celsius symbol, just go up and copy and paste it from somewhere else on the test paper. All right, so you must know your formulas. Unless you're in regular chemistry, then there will be formulas up at the top of your test paper. These formulas will be up there. So PV equals PV, that's Boyle's law, sorry. That's the first one that we did where we looked at a balloon underneath a vacuum pump. Then we did Charles's law, volume over temperature equals volume over temperature. We took a balloon from cold to hot, and we saw that when you increased the temperature, you increased the volume. Then we did pressure over temperature equals pressure over temperature. That's Gay-Lussac's law. Just like when you increase temperature, volume increases. When you increase temperature, pressure increases. So I say, whatever way temperature goes, so does the other variable. But if you look at Boyle's law, there is no temperature. That's why Boyle's law is an inverse relationship. So if pressure goes up, volume goes down. Then you can solve all of these problems, Boyle's, Charles, and Gay-Lussac's laws, by using the combined gas law. It's a combination of all of the 3 gas laws, and you can use it whenever you need to solve any of these problems. And if you just don't have that variable, you just leave it out of your problem. Every one of these laws, Boyle's law, Charles' law, Gay-Lussac's law, and the combined gas law, require you to have some change in a circumstance. You see how each of them have 2 of each of the variables. That means your problem is going to have to imply that there is a change in circumstances. That's different than the ideal gas law. The ideal gas law does not have a change in circumstance and is the only one of the gas laws that you can solve for the number of moles. And that means it's the only one that you can use to solve also for the number of grams. Here are some gas concepts. That's based on the gas laws. If a gas in an expandable container, say a balloon, is cooled, the volume of the gas will, think back to your lab, we did this. If you cool down the balloon, what happens to the volume? It decreased. If the pressure surrounding a gas in an expandable container is decreased, the volume will increase. So remember, if the temperature goes down, the volume goes down. But if temperature is not involved, then the reaction has an inverse relationship. So when no temperature is involved, the opposite things happen with the variables. It's really important to know your units, not only to answer the question, but to be able to determine what kind of question you have. So you need to know that Kelvin is a unit of temperature. Kilopascals is a unit of pressure. Degrees Celsius is a unit of temperature. Torr is a unit of pressure. Liters is a unit of volume. So there are other ones, you could have milliliters, you could have PSI. You need to know your units in order to solve these problems. Which gas law would you use to solve this problem? Assess what you have. Do you see that you have a change in the volume? So even though they gave you a 5-gram mass of this substance, it's of no relevance to the question, because what they're asking you to do is, given a certain pressure, find a certain pressure. And they've given you 2 volumes. Think about the gas law problem for ideal gas laws, which involves mass. That only has one, that's a P, a V, equals an N and an R and a T. It only has one of each of the variables. So you cannot use PV equals nRT to do a problem that has a change in the factors. So this has a change in the factors. It's Boyle's law. Volume and pressure. And they've given you another volume, and you're trying to find the pressure. So plug and chug your numbers here. So P1 and V1, and then they don't tell you P2. You're solving for it, but they give you V2. Always start in your calculator on the side of the problem where you have both of the numbers. Multiply them together and divide by the one that's attached to your variable x. When you solve this problem, you should end up with 0.01225 atmospheres. Why? Because the original pressure was in atmospheres. So the pressure you're solving for will come out in atmospheres. Before I even pick up my calculator with this question that says find the pressure, I already know that the units will be in atmospheres because the original pressure was in atmospheres. Which problem would you use to solve this problem? Assess the variables. Okay, so this is Charles's law. It's V over T equals V over T because you have a temperature and a volume. And they're asking you, at what temperature will the volume be 1.12? So you'll notice I've showed you here, don't forget, on the bottom of this, you need to take that 89 and add the 273. And when you solve for x, don't forget, because you're solving for temperature, you need to take away 273 at the end. Okay. So the path that you take, first add 89 to 273. Once you get that number, multiply it by 1.12. Then divide it by 0.67. That number is your temperature in Kelvin. Take away 273. So your number is 0.67 over 362 equals 1.12 over x. You always take the path where you have both numbers and divide by the number that's connected to your variable. That's 605 Kelvin. But don't forget, we have to report in Celsius. So you solve in Kelvin, report in Celsius. So that's 332 degrees Celsius. The volume of a gas is increased from 3 to 9 liters while the temperature is held constant. How does the gas change? What variables are we looking at here? We're looking at volume and pressure. So volume and pressure doesn't involve temperature. So remember, that is an inverse relationship. So if volume is going up by 3 times, then the inverse of 3 times is 1/3. So since the volume increases by 3, the pressure will be 1/3 of the starting amount. Assess this problem, pause the video, and come back and solve it. This is a combined gas law problem. It has all the variables in it. It's got 2 of some of the variables, so we know it's not a PV equals nRT problem because I have 2 temperatures and I have 2 volumes. What I'm missing is another pressure. It says at 0 degrees Celsius and 1 atmosphere of pressure, a sample occupies 30 milliliters. If the temperature is increased to 30 degrees Celsius and the entire sample is transferred into a 20 milliliter container, what will the new pressure be? So that's PV over T equals PV over T. You take the path that you have all the numbers for. So that's the 1 times the 30 times the 303. You always take it's cross multiply and divide when you have fractions like this. So cross multiply and then divide. Don't forget, when you are dividing 2 numbers on the bottom, you got to put those numbers in parentheses. So I will walk you through what it exactly sounds like when you put this in your calculator. Here we go. 1 times 30 times 303 equals divided by open parentheses 273 times 20 close parentheses equal sign. When you solve this problem, you'll get 1.66 atmospheres. It's coming out in atmospheres because my original pressure was in atmospheres. Which law would you use? Hopefully you notice that this is an ideal gas law. It's an ideal gas law because it's not asking you to change any circumstances. You do not have 2 of any variable. You have a pressure of 3.81 atmospheres. You have a volume, which unfortunately here is given to you in milliliters, which means you have to convert that to liters by moving the decimal place 3 places to the left, equals the number of moles. By the way, that's going to be my variable because the question says how many moles. The R value, which they must present to you, that is not a memorized fact for our class. It'll be up at the top of your test paper. And they've given you a temperature. They've given it to you in Celsius. Remember, you must do this problem in Kelvin. When you set up the problem, it looks like PV equals nRT. Start on the side where you don't have a variable in your calculator. So that's 3.81 times 0.044. And divide by, and since you're dividing by 2 numbers, open parentheses, 0.0821 times 2.98, close parentheses, equal sign. Whenever you divide by 2 numbers that you must multiply first, they have to be in parentheses. So that's going to equal X. So it's these numbers and then divided by those two numbers multiplied together in parentheses. You come out to 0.0069 moles of whatever this substance is. Which law would you use to solve this problem? Do you see immediately that you have two different pressures? And they're asking you to have a change in condition. What will be the new volume? So this is not a PV equals nRT problem. I have pressure only and volume. When I only have pressure and volume, it's a Boyle's law problem. That's PV equals PV. So set up your variables. Start on the side of the problem that you have both of the numbers and put that in your calculator first. So 99 times 300, and then divided by the number that's attached to your variable, divided by 188, and you will get 1.58 milliliters. Why is it in milliliters? Because it asked what's the volume, and the original volume was in milliliters. What would you use to solve this problem? Hopefully you see it's an ideal gas law problem. You only have one of each of these variables. It says, what is the pressure? So I'm solving for P of a 0.108 mole sample. That's my N. At a temperature of 20 degrees Celsius. Once I convert that to Kelvin, that will be my T. And the volume is 0.505, so 0.505 liters. That's already in liters, so that's already in ideal conditions. Remember, you do need an R value to solve this problem. Set up the variables that you know, PV equals nRT. Start with the side of the problem where you have no variable. So you're going to multiply 0.108 times 0.0821 times 293 divided by the number attached to your variable, which is 0.505 liters. This number is going to come out in atmospheres because the question said, what is the pressure in atmospheres? That's what made you have to go get the R value for atmospheres. You can't just pick any R value you want. It is ideally the one that goes with your pressure. Which gas law would you use to solve this problem? This is asking you to convert to a new volume at standards that are temperature and pressure. So this is a combined gas law problem because they're asking you to convert to a new situation where the temperature and the pressure is changing. So the balloon starts out at 0.998 torr. You've got to know that it's in torr to know what the standard is in torr. The standard for temperature is always 273. So these are the original conditions, 0.998 torr, 2.1 liters, and 303 Kelvin. They're asking you to convert that to standard, which is 760 for torr and 273 for temperature. That's 0 degrees Celsius, 273 Kelvin. You're solving for a new volume. This is a large cross multiply and divide problem. Remember, you always start on the cross multiply that has all the pieces. So 0.998 torr times 2.1 times 273 equals, divided by, open parentheses, 303 times 760, close parentheses. Your answer is going to come out in liters because the original volume, 2.1, was given to you in liters. So your new answer is 0.0025. Now your calculator could come out in scientific notation. So if your calculator says 2.5 e negative 3, that is the same number as 0.0025. You have to know that. That's part of our curriculum. If a balloon is heated, hey, we did that. What happens to the volume of the air in the balloon if the pressure is held constant? So temperature up, volume up. Whatever temperature does, the other variable does. So temperature up, volume up. Vice versa, temperature down, volume down. It works that way for pressures as well. Temperature up, pressure up. Temperature down, pressure down. That's why when you have a temperature in your problem, I say whatever T says, that's temperature, the other variable does it. All right, so I've got a gas in a sealed container with a pressure of 125 kilopascals at a temperature of 30 degrees Celsius. If the pressure is constant and in the container, if the pressure in the container, increases, it's not constant. I read container as constant. If the pressure in the container is increased to 201, so you see you have a change in condition, what's the new temperature? A change in condition means it's one of the gas laws that you can use the combined gas law to solve. Or this is just because it only has pressure and temperature, a Gay-Lussac problem. So that's P over T equals P over T. Set up your question with the pieces that you know. Don't forget to change your temperature to Kelvin. Start on the path that you have both of the numbers. That's 303 times 201. And divide by the thing that's attached to your variable. That's 125. So you start on the path where you have both numbers. Remember, it's cross, multiply, and divide. So the number is going to come out to 214 degrees Celsius. Okay. Remember, it's going to come out in a Kelvin number, and you're going to subtract 273. Air is trapped in a cylinder fitted with a piston that occupies of certain volume, 145.7 milliliters, at a certain pressure, 1.08 atmospheres. What's the new volume? Do you see you're having a change in conditions? That means you're going to be using one of the named gas laws or the combined gas law. This only has volume and pressure. So this is Boyle's law. That's PV equals PV. Set up the variables that you know in your problem. Start with the side in your calculator where you have both of the numbers. That's 1.08 times 145.7 divided by 1.43, the variable that's attached to your x. And you will get 110 milliliters, or they may ask you to solve it and answer in liters for some reason. Then that would be 0.110 liters. To move from milliliters to liters, you move the decimal point 3 places to the left. The Celsius temperature of 3 liters of a gas sample is lowered from 80 to 30. What's the resulting volume of gas? So we've got a change in temperature. They're asking you to solve for a volume. That's Charles's law. V over T equals V over T. Solve the path that you have all of the numbers for. 3 times 303 divided by 353. You always start with the path where you have both numbers and divide by the path that has the variable on it. Your answer comes out to 2.58 liters. They gave you a volume in liters. Typically, you would then solve in liters. The pressure of a gas sample of helium in a 1 liter container is 0.988 atmospheres. What's the new pressure if the sample is changed to a 2-liter container? So that's Boyle's law. PV equals PV. So set up your problem. 0.988 times 1 equals x times 2. Start with the side that in your calculator that you have both the numbers. So that's 0.988 times the 1 divided by 2. So you always start with the side that you have both of the numbers and divide by the one that's attached to the x. So if your volume goes up, you'll notice your pressure is halved because Boyle's law is an inverse relationship. What would you use to solve this problem? You'll notice in this problem, it's saying to determine the temperature, excuse me, of 2.49 moles of gas in a 1-liter vessel at 143 kilopascals. You know this is an ideal gas law problem because you only have one of each of these different circumstances. You do not have a change in circumstances. They are asking you to determine the temperature. So you're trying to find the T out of PV equals nRT. There's only one P, there's one V, there's going to be one N, one R, and it will solve for one T. Unlike a combined gas law problem where there is a change in circumstance. All right. So when you solve it, you have two sides of this equation, the PV and equals the nRT side. The side that goes in your calculator is the side where you have no variables. So that's 143 times 1. Then when you hit divided by, you have two numbers on the bottom because there's two numbers attached to this x. You have to open parentheses. After you hit divided by, you open parentheses and say 2.49 times 8.31 and close parentheses. Your answer comes out to 6.9 Kelvin. That is not how we report. We solve in K and report in C. And so we have to take away 273. If you have K, you take it away. That's 273 is taken away. Don't forget, they're going to provide you with the R value. That's not something you have to have memorized. That's where this 8.31 number came from. The only unknown that you had at a PV equals nRT was the T, because the R value is provided for you at the top of the test by your periodic table. A balloon at a pressure of 0.998 atmospheres and a temperature of 30 degrees and 2.1 liters, what will the new volume be at standard? You'll notice you have a change because what's the new volume? Of circumstances, and you have all three of the circumstances. That makes this a, you guessed it, combined gas law problem. We solve it with the formula PV over T equals PV over T. Take a moment to pull out the numbers and determine the standards for the conditions that they have given you. Hopefully you set it up as P 0.998, that's atmospheres, V 2.1 liters, over T, and you took 30 and added 273, equals 1 atmosphere is the standard for atmospheres, and 273 is the standard for temperature. So what I'm solving for is the new volume. Take the path that you have all your numbers on. That's the 0.998 times 2.1 times 273. Remember, it's a cross multiply. And then hit divide, open parentheses, 303 times 1, close parentheses. Your new answer is 1.89 liters. That will be the new volume if you change your conditions to standard conditions. what change would cause a decrease in pressure of a contained gas? So there are several circumstances. If you're going to decrease the pressure, remember you could decrease the temperature because whatever you do to temperature, the other variable does the same thing. Or if you remember that in Boyle's law, it's an inverse relationship. So what would cause a decrease in the pressure? It would be an increase in the volume. So pressure goes down if volume goes up. Those are the two ways that I could have a decrease in the pressure of a contained gas. Now, please keep in mind, they can ask you the other way. So make sure you know your circumstances. Which law would you use to solve this problem? Hopefully you see it is an ideal gas law problem. And that is because you are determining the temperature required for a certain amount of moles of gas in a balloon at a certain pressure. So you only have one of each of these variables. You only have one PV equals nRT. They're going to give you at the top of the test paper the R values. You have to know you've got to get the R value for atmospheres because the pressure they gave you was in atmospheres. When you plug in the numbers that you know, the P is in anything, but you have to get the right R value. The volume has to be in liters. This one is in liters. The N has to be the number of moles. They have given you the number of moles. The R value has to be the one that goes with atmospheres. We went and got it from the top of the test. And the temperature is going to come out in Kelvin. And when it comes out in Kelvin, we're going to convert it to Celsius. What do? I start with the side of the problem where I have no variables. So that's the side P and V have no variables left. We know both those numbers. So 0.988 times 1.2 equals divided by, open parentheses because I'm going to multiply two numbers, 0.047 times 0.0821, end parentheses, equal sign. And then that's going to give me 307 Kelvin. But remember, we got to report in Celsius. So that means take away 273. So that's 34 degrees Celsius. Determine the temperature required for 9 grams of water vapor to fill a container up to 1,000 milliliters under 1.2 atmospheres of pressure. So what gas law would I use to solve this? Well, they have given me grams. Okay, I need moles for this problem. But you'll notice there's no change in circumstance. They're telling me to determine the temperature. So no change in circumstance means an ideal gas law problem. But for an ideal gas law, you have to have ideal conditions. What does that mean? First of all, your pressure can be any unit, but I have to use the right R value. So what pressure do I have here? Atmospheres. So I first have to go get the R value for atmospheres. It's located at the top of your test in a section of R values. So what is the pressure? We already said it's 1.2 atmospheres. What is the volume? In an ideal gas law, the volume has to be in liters. And here they gave me milliliters. So move the decimal place 1, 2, 3 places to the left. And that's why 1,000 milliliters equals 1 liter. Equals the R value has to be in moles. But they gave me grams of water. Do I have a way, back from stoichiometry, to change from grams to moles? Yes, we use our mole map. To go from grams to moles, we have to divide by molar mass. So 9 grams of water is what they gave me. And the molar mass of water is 18 because it's two hydrogens, each with one, and one oxygen, which weighs 16. So that's 18 grams per mole. So that means 9 grams of water is 0.5 moles. That's where I'm getting the 0.5 moles, because the molar mass of water is 18 and they gave me 9 grams. I've got to go back to my stoichiometry knowledge to answer that piece of the problem. Then the R value I simply go get for atmospheres, and I'm solving for K. So you start in your calculator on the side of the problem where you don't have any variables. So you have a K variable over here. So 1.2 times 1 equals, so divided by parentheses 0.5 times 0.0821 end parentheses. That gives you 29.2 Kelvin. But remember, we don't report in K, we report in C. And so it is 244 degrees Celsius. I know this was really long. Hopefully you paused the video and solved the problems along the way and made sure that you were calculating each problem and getting the same answer that I did. Good luck on your test.